11.4 is talking about three-dimensional figures. As you see below here, these are all three-dimensional figures. I want to start on page 331 with our definitions. The first one, a polyhedron. Polyhedron is a solid that is bounded by polygons. And we have talked about polygons. We know what polygons are, right? Square, triangle, rectangle, pentagon, hexagon, octagon, all those. Okay? The polygons that bound the polyhedron together are called faces. So, an edge is a line segment formed by the intersection of two faces. A vertex is a point where three or more edges meet. Oh, not faces, edges. Before we get into these next definitions, just with these first four, I want to draw a polyhedron, and then show you the vertex, the edge, and the face. If we had, oh, this is bad drawing start. Sorry, hold on. Okay. Yeah, there's a trapezoid. So there's these edges that come off of it. Need to make okay, there we go. This is a 3D image. This is a polyhedron. The face is any one of these sides. This is a face. This is a face. Face. Okay. All of those polygons are faces. A vertex will be right here. Here's a vertex. Here's another vertex, right? Vertex. There's multiple vertices. That's plural for vertex. And then an edge. An edge is this thing. Okay, this is an edge. That's an edge. Back here is an edge, right? There's a bunch of edges on this figure as well. to be talking a little bit about cross-section. A cross-section is the intersection of the plane and the solid. I'll do my best to draw that as well. Solid of revolution, we'll talk about it later. We're not going to get too far in depth about that. Same with the axis of revolution. So, drawing the cross section, let's see if I can draw this here. If I have a cube, which is square, and I can draw a cube decently. Okay, there's a cube. Yep. Let's say I have this cube and I have a rectangle that kind of splits my cube into two parts. Okay. This right here, inside my cube, is the cross section, and it forms a rectangle. Okay, so we're going to be talking about what shape does the cross section create. In that case, it was a rectangle. Go back up to the top. Here's some examples of platonic solids. Okay, each of these solids has congruent regular polygons as faces. Sorry, I will. Okay, so first we have a tetrahedron on the left, a cube, an octahedron, a dodecahedron, and an icosahedron. And these are words you might not have ever heard of before in your life. We're going to just go through vertices, edges, and faces of each of these five shapes. So, tetrahedron, we're going to first talk about the vertices. And remember, vertices are the points. Point here, point here, point here, point here. So in our table, there are 4 vertices in a tetrahedron. Okay, 4. The edges are 1, 2, 3, 4, 5, and 6. So there are 6 edges. And the faces. How many faces? Well, there's one right in front here. 1. There's 2 here. There is 3 on the bottom. And then there's actually a 4th one kind of on the back side here. So there's 4 faces. Let's talk about vertices of a cube. Vertices of a cube, there is 1, 2, 3, 4, 5, 6, 7, 8 vertices. How many edges? There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And how many faces? 1, 2, 3, 4, 5 on top, 6 in front, 7 on the side, and 8 on the bottom. 8 faces on a cube. Okay. Sorry, I believe I miscounted that. Hold on, let me count these faces again. Top, bottom, side, side, front, and front. So there's 6 faces on a cube, just like a die, right? A die is a cube. 6 faces. All right, an octahedron. Octahedron, count the vertices. There are 1, 2, 3, 4, 5, 6. 6 vertices of an octahedron. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and in the back, no, 11? Alright, gonna have to recount. There is 1, 2, 3, 4. There is 5, 6, 7. 8 on the side, 9 in the back, 10 on this side, and 11. Yeah, 11 edges. Okay. And faces. There are 1, 2, 3 in the back, 4 on the side, 4 triangles on top, 4 triangles on the bottom. That makes 8 faces. All right. Next is our dodecahedron. I'm going to bring this 4, this 8, and this 6 up. 6, 11, and 12, or just 12 and 11. Okay. Dodecahedron. How many vertices? That's a lot of vertices. And I'm not going to count all those. Let's see if we can create a rule instead of counting. Okay, which is actually what they're talking about or what they're asking for on the next page. What is the relationship between the numbers of vertices, edges, and faces of a polyhedron? Answer is V minus E plus F should equal 2. Or, if we add E, it'd be V plus F equals edges plus 2. I like this one a little bit. Vertices plus faces. So if we go up top here, vertices plus faces. So if we took 4 and 4, which is 8, so we have 8, is that equal to edges 6 plus 2? In that first example, yes. In the next example, cube, we take 8 plus 6, which is 14. Is that equal to 12 edges plus 2? Yes, it is. octahedron. Octahedron is, we're going to take our vertices plus faces, 6 plus 8, which is 14. Is that equal to our edges plus 2? I did that wrong. So I counted the wrong number of edges in the octahedron. Okay, I'm going to count, just to make sure that octahedron, it should be 12. 12 edges. Okay, so there's 1 here, 2, 3, 4 that cover that face. There's 5, 6, 7, and 8 on the back. 9, 10, 11, and 12. So there is 12 edges. I miscounted. Okay. So if we know 2 of the vertices, if we know 2 of the 3, either a vertice and edge, a vertice and a face, or an edge and a face, then we can figure out the other one just with that simple formula. Okay? V plus F is equal to edges plus 2. So vertices plus faces is equal to edges plus 2. If we count the number of faces on this one, 1, 2, 3 on the back, 4, 5, 6 down here, 7, 8 on the very back, 9, 10, 11, and 12. There's 12 faces in the dodecahedron. 12 faces. And there are how many vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 20 vertices. Can we figure out the number of edges? Yeah, with our simple formula. V plus F is equal to edges plus 2. Well, the vertices is 20, plus the faces, 12, is equal to edges plus 2. So 32. We subtract 2 from both sides. There are 30 edges. 30. Okay. We're going to skip that last one. We're going to get into some extra practice here. Types of solids. There is polyhedra and not polyhedra. The way I think about it, any round object, cylinder, cone, or sphere, is not polyhedra. Anytime we have a polygon as our base, here we have a square as our base, right? Or a triangle, or a rectangle, or a pentagon, hexagon, then it is a polyhedra. Okay, so numbers 1 and 2. Tell me whether a solid is polyhedra. If it is, name it. Okay. So for that first one, number 1, it is, yes. It is an octahedron. How do I know it's an octahedron? It has 8 faces. It has 8 sides. 4 triangles on the bottom, 4 triangles on the top. Okay. Number 2, is this a polyhedron? No. It's a round object. No. Moving on. Describe the cross-section formed by the intersection of the plane and the solid. So all we're looking at is what shape is formed by the cross-section. What shape is this? Okay. So if a rectangle went through a pyramid, which is what we have here, what shape do we have? And it looks like it is a square. The cross section on the next one is a shaded thing here, which is what polygon? It's a triangle. This one looks like it kind of goes in the pyramid at a little bit of an angle. I'm going to form this shape, which is, if we remember from chapter 7, it's a trapezoid. And this shape here in the dark shaded area has 1, 2, 3, 4, 5, 6, 7 edges, or 7 sides, which is a heptagon. 7 sides, heptagon. 7 and 8 we're not going to really do. This is that rotating figure. This is what we called a solid of revolution. All it says is we would rotate this figure around this line. Okay. And we would rotate this figure number 2 around this line. I can draw number 2 a little bit better. All it would look like is the final product would look something like this. Okay, it's a round object, and it's not so steep. They're not such a big circle, kind of rounded here and rounded back there. And so you can imagine this shape in number 8 just rotating around that line. That's the figure we would get. All right, and we'll maybe talk a little bit more about that in class, but not much. That's about it.